Welcome to our first of our last two units that are both going to be dealing with trig. You learned a little bit of trig in geometry, and then you did a lot more in depth with trigonometry and Algebra 2. So we're going to be picking up with the Algebra 2 material. Some of it is going to be review, maybe a new concept here or there. But we're going to be working through our trigonometry. When we do our trigonometry, we usually like to use Greek letters to represent our unknown angle values. So theta, alpha, beta, and phi. So if you see these are just representing missing angle values or unknown angle values. But we're going to start first by talking about how to draw the angle. And now, a lot of times, especially in geometry, you would just draw an angle. Usually we'd have, maybe one side is horizontal or anything, but we would just draw two rays meeting at a single vertex, and that would be our angle. But when we talk about this in terms of trig, we do care about the way it opens and what direction does my angle open, because unlike in geometry, we can have negative angles with our trigonometry. And the reason why angles are negative is just the direction in that it opens. That's all it is. And the negative just tells me which way I opened up my angle. So when we're drawing these angles, each angle is going to have two different sides. It's going to have the initial side and the terminal side. And which one's which, again, depends upon the way we open that angle. So the angle on the left here, the initial side is the one that's down at the bottom, and it opens up to that terminal side here. And then we have our vertex as well. And when we draw them, when we're going to draw them in class, we are going to draw them in what is called standard position. And you would have talked about this last year in Algebra 2. Standard position, that initial side is always the positive x-axis. That's going to be the initial side. And it's going to open up to the terminal side. And so the picture that we have here, this one opens up in a counterclockwise direction. And so that means that this is going to be a positive angle value. If we were to draw in another angle, let's say in standard position still, so I still have that same initial side, but this time I open in the clockwise direction, then that's going to have the negative angle value. So unlike in geometry where all the angles were always positive, here we can have either positive or negative, and it just depends on, are we opening our angle in the counterclockwise direction, so positive angle, or the clockwise direction, so the negative angle. But we're going to focus a lot on the standard position, and then do we open up positive or negative? Do we open up counterclockwise or clockwise? That's going to tell me if it's positive or negative. And we're going to do a little bit with that, but we're not going to focus a whole lot on that one. Again, positive or negative opens counterclockwise or clockwise. Angles in college algebra, just like they were in Algebra 2, can be measured in either degrees or in radians. And so we're going to go and we're going to convert back and forth between the two. Remember, degrees, when we write them, is always going to have that little degree symbol. So, 35 degrees. And most of the time, but not always, radians is going to have a pi. So something like pi over 3. You could have just 5, like 5 radians. And sometimes we'll write RAD to represent radians. But if it's missing the degree symbol, that's going to be the key thing that represents that it's radians. Okay? So when we're talking about our angles, key things we need to know, and you've got this on your note sheet. You've got the initial side and the terminal side, and then the vertex. Those are the pieces or the parts of my angle. We're going to need to know how to draw them in standard position. When do we have a positive angle? When do we have a negative angle? And then the last two are the complementary angles and our supplementary angles. Now, if you remember from geometry, these are geometry terms. Our complementary angles are always going to be two angles that add to 90. Oops. that. And then our supplementary angles are two angles that add to 180 degrees. So these are going to come in handy when we start talking about reference angles and those sorts of things. How to find those reference angles on our unit circle. So we are going to be dealing with the unit circle like you did last year in Algebra 2. We're going to be thinking them through in terms of the triangles that are made out of them. But we've got our complementary angles, or angles that add to 90 degrees, whereas our supplementary angles add to 180. Excuse me. So radian is another way to measure our angles. And this comes from the radius being sort of wrapped around that circle. It's how many times can we wrap that radius around the circumference of my circle. And so if you think through back to what the circumference formula for a circle is, the circumference is 2 pi r. So for me to take my radius and to be able to wrap that around my circle, I can do that 2 pi times. So we would say that in radians, 1 revolution is 2 pi. But if I think about that in terms of degrees, 1 revolution in degrees is 360 degrees. So if I know that 1 revolution in radians is 2 pi and 1 revolution in degrees is 360, that allows me to make this equation that 2 pi radians has to equal 360 degrees, or that 1 pi radian is equal to 180. And it's this conversion, those should have those degree symbols there, it's that conversion that pi is equal to 180 degrees that's going to allow me to go back and forth between the two units of measurement. So before we start converting, there are a couple angle values, both in degrees and radians, that we are going to want to know, and you maybe will remember some of these from last year. Our acute angles, the ones that are less than 90 that we want to look at, are pi over 6, pi over 4, and pi over 3, which if we convert these into our degrees, this is 30 degrees, 45 degrees, and 60 degrees. And the reason we want to know these are the angles in those special right triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. And then pi over 2, which is the same as our 90 degrees, pi, which is 180, and then 2 pi, that's that full revolution, that's that 360 degrees. Those are the angle values, the common ones that we're going to be using most often in both radians and in degrees. And those are the ones that are going to help us in our unit circle to find specific values, because those are, especially the 30, 45, and 60, those are the angles that come from those special right triangles where we know those side length patterns to help us find missing sides quicker than just using sine, cosine, and tangent. So we're going to practice drawing some angles. We are going to draw all of these in standard position, which, remember, standard position, the initial side needs to start on that positive x-axis. So we're going to start with the initial side here, positive x-axis, and then you're either going to open out, clockwise or counterclockwise, and that depends on if it's negative or positive. And we want to try and get these to be as accurate as possible. So we want to remember that this up at the top, that like northernmost point is the 90 degrees. Westernmost is 180, 270, and then 360 to go all the way back around. But that 360 is also like 0 degrees if we didn't open up at all. If we did these in our pies or radians, if we were to do these in our radians, we would have no longer the 90 degrees and the 180, but rather we would have those pi over 2, pi, 3 pi over 2, and then 2 pi. Also starts at 0, so either 0 or 2 pi. And so that's going in this counterclockwise direction, counting up. All right, so we're going to do some drawing now. We're going to start with a 50-degree angle. So 50-degree angle, we are going to begin. We're going to have that, we're going to want to draw in that coordinate plane. We don't already have it on there. And we want to start by drawing in that initial side. And that initial side, again, is going to start on that positive x-axis. What I want to do is I want to open this angle up in the positive direction. So because this is positive, I want to open in the counterclockwise direction. So I want to open this way, but I only want to open up 50 degrees. Up at that northernmost point, that's that 90-degree mark. So I don't want to go all the way to the 90 degrees. I only want to go 50 degrees. And so if I were to stop exactly halfway, that would be 45. So I want to go slightly more than 45 degrees, so slightly more than halfway. And that would give me my opening up in that counterclockwise direction, positive 50-degree angle. All right, so we've got a couple more that we're going to do. 160, 405, negative 135. So that means we're going to open up in that negative direction. And then negative 300. So go ahead, take a minute. You can pause the video. Try drawing these, remembering that when you've got those angles larger than 90, you want to use those other touch points. Of the westernmost point's 180, down at the bottom is 270, and then 360 is all the way around. And so when we get to that 405, that one's going to be special because that's more than 360, so that's more than one full revolution. So see if you can remember how to do that from Algebra 2. Take a minute, pause the video, and then come back and check your work. All right, so hopefully you're able to get these graphed. Now, positive 160, you can use that touch point of 90 up at the northernmost point and 180 at the western point, and say the 160 is between those two, and it's a lot closer to that 180. It's only 20 degrees off, so it should open up more like this, more than halfway between those two there. Our negative 135, that one is going to open up clockwise. So when I go and do those touch point points, now I want to go in clockwise. That bottommost point, whereas above we thought of that as positive 270, can also be thought of as negative 90 degrees. So starting at that initial point, if I move in the negative direction, so I move in the clockwise direction, that bottommost point would give me negative 90. And then the westernmost point would give me negative 180. And so again, I want to be halfway between those two. And this time I'm actually exactly halfway between those two. So I want to make that line go halfway between that northern and those western poles. So I get negative 135. And again, you're opening clockwise this time. And we're going to come back to the 405. And the negative 300, again, you're opening clockwise. And you want to use those touch points. And just like before, now when we start counting, we're going to start negative numbers. We're going to start at the bottommost point with negative 90. Western is negative 180. Northern is negative 270. And if I went all the way around, this would have gotten me to the negative 360 back at that initial, that positive x-axis point. I don't want to go all the way to negative 360. I only want to go to negative 300. Well, that's 60 away from the 360, negative 360, or 30 away from that negative 270. So it's a little bit closer to the negative 270, that uppermost northern pole. And this time I am opening up again in the clockwise direction. So it is that larger angle, the one that almost goes all the way around. Now 405 is special. It's a little bit different because it is larger than a single revolution. And so that's okay. It just means that angle is going to loop all the way around once and open up a little bit more. So that's why we want to, after we get that one revolution of 360 degrees, we want to go and continue on with those touch points. So that northernmost point, 90 degrees, is the same as 450. That's 90 more than that 360. So if I kept going, northernmost point's 90, western 180, southern 270, eastern, that initial point, 360. And then I keep going. 90 plus 360 gets me back to 450. So that upper point, it's not just 90 degrees, it's where 450 would end up as well. And so I want to be somewhere between that 360 and that 450. And 405 is actually right in the middle. So my terminal side is going to go right in the middle. But when I draw in the angle, it's not just the little angle, it makes that whole loop, that entire loop around. So I do want to make sure that I draw in that entire loop around and say my angle is more than one full revolution. So this also works if we were doing negatives. If it was negative 405, we would have gone in the clockwise direction. We would have done a full loop around and would have gone a little bit further past. All right, we're going to do the same thing now, but now we're going to do it in our radians. And so we're going to have those same touch points. Now, a couple ways to think through our radians. You can try and remember what we did in Algebra 2 to help us with that. We can do our touch points again where we have the, instead of 90, 180, 270, we can have our pi over 2, our pi, our 3 pi over 2. Now these are all about fractions. Multiples or fractions, divisions per pi. And some people, not big fans of that, but hopefully this doesn't get so difficult. Instead of counting by nines, we're going to be counting by pi's over 2. So up at the top, we have 1 pi over 2. That's the same as those 90 degrees. And then when I go to that westernmost point, right there, I want to add in another pi over 2, which would give me 2 pi over 2. But 2 pi over 2, the 2's canceling, is just going to give me pi. So I have pi down here. And then to get to that southern point, I want to add another pi over 2. So that pi, remember, that was 2 pi over 2. And I want to add in another pi over 2. So every fourth of a turn is pi over 2. Every 90 degrees is pi over 2. So that gives me 3 pi over 2 down at the bottom. And then if I added in another pi over 2, that would give me 4 pi over 2. But the 4 over 2 cancels, simplifies to just be 2 pi. So those are my touch points. This could also be the 0 degrees. Okay, so it's either 0 or 2 pi. But when I draw this in again, just like before, my initial line, my initial side is that positive x-axis. That's where that 0 degrees. If I didn't open up my angle at all, that would be my angle. And I want to open this up to a pi over 4 angle. So I want to think about which of those sections would pi over 4 fit? Would it fit between pi over 2 and pi? Would it fit between 3 pi over 2 and 2 pi? So this pi over 4, this fits between 0 and the pi over 2. Okay? Pi divided into 4s, it's bigger than 0, but it is smaller than if I took pi and just divided it into 2s. So it's going to be in this first quadrant here. This is our first quadrant here. This is where it's going to land. And it's actually going to be exactly in the middle. Pi over 4 is exactly halfway between 0 and pi over 2. It's half of pi over 2. So this angle here, again, it's positive, so I'm going to open up in the counterclockwise direction. That gives me my pi over 4 radians. And I don't do the little degree symbol because we're talking about radians, not degrees. Okay. If we were to continue on and do this next one, this negative 2 pi over 3, if we did that one next here, because it's negative, I am going to open up in the clockwise direction. So when I go and put my touch points in, I'm going to start down at that southernmost point. And this time, instead of having that be that positive 3 pi over 2, this is going to be negative pi over 2. And instead of adding pi's over 2, I want to subtract them, which is just like adding, but with a negative symbol out in front. So I have negative pi over 2 minus pi over 2 is just like negative in parentheses, pi over 2 plus pi over 2, which gives me with negative pi at the westernmost point. And then I subtract another pi over 2, and I would get negative 3 pi over 2. And then that easternmost point, that's either 0 where we start or negative 2 pi. Okay. So we want to draw in this negative 2 pi over 3. So we need to figure out where does that fit. And so we can kind of ignore the negative for a second and just think about 2/3 pi. I've got 1/2 pi down at the bottom, negative 1/2 pi down at the bottom. And then I've got negative pi on the left and the westernmost side, negative 3/2 pi over at the top. And so I want to think about 2/3 as a fraction. Where does that fit? 2/3 is less than 1. So I'm not going to make it all the way to that negative pi. But is 2/3 bigger than 1/2? It is. 2/3 is bigger than 1/2. It's just a little bit bigger, but it's bigger. And so since 2/3 is bigger than 1/2, but smaller than 1, we're going to be down here in this third quadrant. Dealing with the negatives. So I'm going to fit in between the negative pi over 2 and the negative pi. And that 3 over 2 can easily become something over 6 by multiplying both sides by both top and bottom by 3. So I can multiply by 3 over 3, and I would get 7/6, and I want to compare that to 9/6, and that is smaller. So I'm going to be between that 1 and that 3/2. So I am going to be closer to the 1, because 7 is closer to 6. 1 is going to be 6/6. So it's going to look something like this, and it is positive, so I want to open in that counterclockwise direction. So I get my angle of 7 pi over 6. All right, now we can convert back and forth between our radians and our degrees, and this is all going to be using that relationship of pi radians is equal to 180 degrees. So if you think back to when you took chemistry and you had to do those unit conversions, you would always multiply by a form of 1. And so if pi is equal to 180, then my form of 1 would be either pi over 180 or 180 divided by pi, depending on if I want to convert from degrees to radians or radians to degrees. And so the way I always remember this is whatever I'm trying to get rid of. So if I'm converting from degrees to radians, I need the degrees, that 180, to be in my denominator. So let's say I had an angle value of, let's do 90 degrees. We already know that that one's supposed to be pi over 2, so that should be a quick, easy. I want to multiply this by pi over 180. When you were in chemistry, you were trying to cross off the units when you're converting units. Same thing as here. If you've got a degrees in the numerator and you have a degrees in the denominator, those degrees cancel. And so I'm left with just this 90 pi, because I don't actually want to multiply through by the pi, divided by the 180, but I do want to reduce that fraction. So you can use your calculator to help you. We wouldn't put the pi in. I would just do 90 over 180, and that would reduce to 1/2. So that would give me my pi over 2. So 90 degrees. When we multiply to convert, we want those matching units, one in the numerator, one in the denominator. So since we have this 135 degrees, I want my degrees to be in the denominator. So that's going to be that 180 degrees, which is the same thing as pi. So pi goes in my numerator. And I multiply across, and I get this 135 pi over 180, and I want to reduce this fraction. So it's this fraction here, this 135 over 180, and you just pull out your calculator. You can reduce it, you know, the old school version you did when you were in elementary school and middle school, but you can do it in your calculator. Get that decimal, and do math frac. Now this decimal is pretty nice. It's 0.75, so you could probably convert that without using your calculator, but you can definitely use your calculator and convert that and get that 3/4 pi, or a lot of times what we do is we put the pi in the numerator. It's the same thing, and get 3 pi over 4. All right, go ahead and do the negative 115. Nothing changes. You're still going to multiply by pi over 180. It just means that if your angle is negative in degrees, it will also be negative in radians. So go ahead and do that, and we'll check our answers in just a minute. All right, so you don't get one of our nicer fractions this time, but we still get it into an improper fraction, and we get a negative 415 degrees is the same as negative 83 pi over 36. So we always want to convert. This is definitely one that I would use your calculator for to do that math frac. We can go in the different direction as well. We can convert from radians to degrees, and it just means we're going to flip the fraction that we multiply by. Instead of doing pi over 180, this time we're going to multiply 180 divided by pi. And remember, we want to cancel out those pi's. And so since I have a pi in my numerator, I want to put pi in my denominator in order to cancel. So I have 180 over pi. And it is true, those pi's will cancel. So all I'm left with now is that 5 times 180 divided by 4. And just use your calculator to help you with this. You should get 225 degrees. So rarely do we get fractions for the degrees. Vast majority of the time you will get a fraction if you're doing conversion to radians. So radians, a lot of them are fractions. Most of the time our angles, when they're measured in degrees, are whole numbers. And again, just like with the other one, when it's a negative degree value, it's going to be a negative radians. If it's negative radians, it's going to be negative degrees. So here we're going to have that negative 7 pi over 12. It just means my final answer is going to be negative. I still want to get rid of the pi, so the pi is going to go in the denominator, and 180 is going to go in my numerator. And the pi's cancel, which is great and wonderful and fun. And we're just left with this negative 7 times 180 divided by 12. And you can write out that step, or you can go straight to your calculator and do negative 7 times 180 divided by 12, and you would get the negative 105. So we get negative 105 degrees. Okay, so it's all about that relationship that pi radians is 180 degrees. And just like you did in chemistry, however long ago that was for you, when you do those unit conversions, we're going to multiply by that fraction of 180 over pi, or pi over 180. When you have these angles that are drawn in our standard position, you can have different standard position angles land at the same spot. So right here we've got an example of 2 different angles. One's positive, one's negative, that land in the same spot. And so these are called coterminal angles. Coterminal angles, remember, those are 2 different angle values that have the same initial and terminal sides. And the easiest one to see is these positive and negative values. So you remember, starting on that initial side here, these are all in standard position. If I open in that counterclockwise direction, I get positive 150 degrees. Versus if I open in that negative clockwise position, I get negative 210. But they both end up at the same spot. Another way that we can get these coterminal angles is like when we graph that 405 degree angle. If we have these angles that are more than one revolution. So if I take this and I go all the way around once and then end up, I can get another coterminal angle. And that coterminal angle, the one in blue, would be my full revolution of 360 plus that 150 degrees. That once I did that full revolution, I want that additional 150 degrees, which would give me we're going to do some mental math here, 510 degrees. So that is another coterminal angle. And I could have done this again if we went in the negative direction. If we did a full revolution in the negative direction and then went that extra negative 210 degrees, I can do that. And I would have done negative 360 plus negative 210. That would have gotten me another coterminal angle. So coterminal angles, you have both the initial positive and negative, and then you have all these extra revolutions. So by adding another 360, or if you're in the negative, subtracting another 360. So these can give us an infinite number of coterminal angles, because I can keep going around in these circles. I can do 10 revolutions and then end, or 20 revolutions and then end, and it's still a coterminal angle if it ends in that same spot. So this 150 and this negative 210, those two are coterminal. And we want to think about what relationship those values have to each other. And it might actually be easier to think about this in terms of a positive 210. That negative 210, the reason why that angle is negative is just because it's opening in that clockwise direction. That's the only reason why it's negative. It's because it's opening in the other direction. So what happens with that 150 and that 210? Together, they have to add to 360. Or if you took that 150 degrees and you subtracted 360, you would get the negative 210. Whether you open positive or negative, if they are coterminal, they're always going to be connected to this 360 degrees. So if I had known that this angle here was 150 degrees, and I'm trying to figure this one out, okay, what's the coterminal angle? One thing you can always do is subtract 360. That will give you the negative coterminal angle. So it's all about these connections, because that full revolution is 360. I can go 150 in one direction, or I can go negative 210 in the other, and that would end up in the same spot, because that together, 210 and 150 add to be 360. They add to make that full revolution. This also works for radians. If we're dealing with radians, instead of doing with 360, we would want to do 2 pi, because one revolution is 2 pi radians. But it's always connected to that. So there's more coterminal angles. We just talked about this. You can keep adding 360 degrees, or you can keep subtracting 360 degrees, and that will give us more and more and more and more and more coterminal angles. So angle in degrees, you can add or subtract the 360, add or subtract multiples of 360. So if you want to do what's 2 more revolutions, you can do 720, but it always works to add or subtract 360. For radians, you're going to add or subtract multiples of 2 pi. So 4 pi, 6 pi, 8 pi. Or you can just keep doing those 2 pi's. Because remember, one revolution, 360 degrees. Oops. That's one revolution. Or 2 pi is our one revolution. And so coterminal angles are just about those revolutions. How many times can we go around and land in the same spot? So we're gonna find a positive and negative coterminal angle for each of these. So we're gonna start with this 240, and it is in degrees. So for a positive coterminal angle, I can just take that 240 and I can add 360 degrees. So for my positive, I can do 240 plus 360, and I can get 600 degrees. So that's a positive one. To get a negative one, I can subtract. So I can do 240 minus 360. That gives me negative 120 degrees. Just write the 0 there. For the second one, which should actually be a B, not an A, my apologies, it says negative 165. So to get my positive, I still want to add, because that hasn't done a full revolution yet. So if I was giving you something like negative 405, if I added 360, that would still give me a negative coterminal, which is fine. To get it positive, I would have to add a second 360. This one, it's fine. I just have to add the 1. To get my positive, again, just like above, we're going to add a full revolution. So I do negative 165 plus 360. And I don't have my calculator, so I'm going to do some mental math. It should be 195. Yeah, it should be 195 degrees. That's my positive coterminal angle. And then my negative coterminal angle, that's going to be whatever I get when I take negative 165 and I subtract 360. And that should give me, let's see, it's going to end in a 5, 2, carry the 1, negative 525. Also in degrees. Okay, so typically, most of the time, to get a positive coterminal angle, you're going to add 360. To get a negative, you'll subtract. There are a few exceptions, but most of the time, that's how it's going to work. For our radians, remember, we're going to add and subtract our revolutions, but for radians, a revolution is not 360, it's 2 pi. So for my positive one here, I'm going to take 3 pi, over 4, and we're going to add 2 pi. And you can use your calculator to help you. We're just going to sort of ignore the pi's. If you want to use your calculator, you can think of this, and I'm going to write this out a little bit more mathematically, but it's 3 over 4 plus 2 times pi. So you can use your calculator to help you and get that fraction and do 3/4 plus 2, which is 2 and 3/4. But I want to do 3/4 plus 2, or 3 divided by 4 plus 2, and then do that math frac. So you can do the conversion. You can make that 2 into 8/4, and 8 plus 3 gives me 11. Or I can do my math frac and do this, what's inside the parentheses. I can do that in my calculator. And then do math frac and get 11 over 4 pi. That's my positive. Negative, same idea. This one might be a little bit easier though in your calculator, except we're going to subtract. So 3 pi over 4 minus 2 pi. And again, you can do those whole numbers. So 3 over 4 minus 2 all times pi, and put that in your calculator and do 3/4 minus 2. Math frac gives you negative 5/4 pi, or negative 5 pi over 4. Okay, same idea with this last one here, negative 5 pi over 9. To get a positive, I want to add negative 5 pi over 9 plus 2 pi. And I can do that in my calculator, negative 5/9 plus 2. You can do that by hand, make 2 into 18/9. But I think it might be a little bit easier in your calculator. And you should get 13 pi over 9 for my positive coterminal angle. And then for the negative, we're going to subtract. So negative 5 pi over 9 minus 2 pi. Again, it might be easier, especially with the subtraction in your calculator. Negative 5/9 minus 2 in parentheses times pi, which should give me negative 23/9 times pi, or negative 3 pi, negative 23 pi over 9. Okay, so adding or subtracting a full revolution gives us these coterminal angles. Okay, we're going to come back to that. We come back to that complementary and supplementary idea. Complementary angles are two angles that add to 90 degrees, or if we're talking about radians, pi over 2. So like pi over 6 and pi over 3, that adds to pi over 2. Got to do a little bit of some, excuse me, some wonderful fraction work there, or your calculator work, but that does work. And then supplementary angles are going to add to 180 degrees. So not quite the same thing we were talking about with the 360, but similar. So if you're asked to find an angle that's complementary to one that's given, you would subtract from 90. So then I want to say what's complementary to 30. You would do 30 minus 90, and you would get 60 degrees. If I gave it to you in radians, you would do pi over 2 minus the angle, and that would give you your angle value. If we're dealing this supplementary, if I wanted to know what's supplementary to 30 degrees, this time we're going to subtract from either 180 or from pi. So if I wanted to know what's supplementary to 30 degrees, I would do 180 minus 30, give me 150 degrees. Okay, so same thing. If I'm doing with radians, I'm just going to subtract from pi instead of 180. So quickly, we're going to find some complementary and supplementary angles. Now, these are in radians, and I know they're in radians, 2 different reasons. 1, there's no degree symbol, and 2, they have a pi. So because they have a pi and they don't have a degree symbol, these are in radians. So for the complementary, we want to subtract these from our pi over 2. So we're going to do pi over 2 minus 2 pi over 5. And just like before, what I would do is that pi over 2 is like 1/2 minus 2/5, and then have that pi out at the end. Make your calculator do this for you. You have a calculator, you utilize it. Do 1/2 minus 2/5, and then hit that math frac, and you should get that the complement to 2 pi over 5 is 1 pi over 10. That's the complement there. So there's our complement. Oops, I keep forgetting that highlighter doesn't work very well. There, not much better. So I get that 1 pi over 10. If I want to do the supplement, I'm not going to subtract from pi over 2 anymore. This time, for the supplement, I want to subtract from pi. So it's pi minus 2 pi over 5. Well, everything has an invisible 1 in front of it. So I can do 1 minus 2/5, all in front of pi. And then I can either make the 1 into 5/5 and do 5/5 minus 2/5, or I can use my calculator. Either way, I get 3/5 pi. So here's my supplement to 2 pi over 5, and here's my complement with 1 pi over 10. So go ahead, try the 3 pi over 4, pause the video, and then come back and check. All right, so you should get the complement to 3 pi over 4 is negative 1/4 pi, and that's okay. 3 over 4 pi is bigger than 90 degrees. It's bigger than that pi over 2. So to get back to that pi over 2, we'd have to subtract. If we were to try to graph this, draw this, that 3 pi over 4 angle would be over here. Whereas the pi over 2, that's that northernmost point. So to get back to that by adding, I have to add in a negative number. So we have a negative angle, negative 1/4 pi. That's the complement. The supplement is positive 1/4 pi. Okay, to get up to 180 degrees, or to get to the pi radians, I would have to add 1/4 pi. All right, so that's it for right now. That was our reintroduction. Hopefully that was mostly a review. If not, hopefully it made sense. We're gonna talk some more about graphing these and finding different values for our sine, cosine, and tangent later on this week. Let me know if you have any questions.